All right, today is lesson 3.1. We're going to be graphing linear patterns. So we're going to take some of these situations that we've been looking at, we're going to put it on a graph and kind of see what it looks like, and then start kind of making some predictions. If we see an equation or we see a situation, what is it going to look like on a graph, and be able to kind of bounce back and forth between the two. So a couple definitions to go over in this section. A constant increase situation, pretty straightforward. It's when a quantity that increases at a constant rate. And then a decrease situation, it's going to decrease at a constant rate. And now the specific part of this that's important is the constant part. So that's going to form a straight line if it's consistently going up at the same rate or going down at the same rate. There's other situations where it may increase, but exponentially, much faster, okay, not consistently. So that's not going to form a straight line. So the big idea for today, constant increase and constant decrease situations lead to linear. When you see that word, we want to get used to that. That means forms a line. You can see the word right in there, and are represented by linear, which again is a line, equations. So what do the equations look like that form a line? Because the equations that form things that are not lines are going to look different. So collinear are points that lie on the same line. So that's just a vocabulary word. If 2 points are on the same line, they're both kind of answers to the equation. We would call those collinear. So you see co, meaning they're both part of it. And then you see the line part in there. So 2 on a line. Discrete, if you didn't find this one in your textbook, it wasn't bolded in, but it is in there. And those are separate points. So when we have a graph, so let's just draw a quick graph. That's when we have points that are separated like this. They're not connected. And then as opposed to a continuous graph where you have a line where everything's connected. So you have points on this line, but everything's connected. Difference between the two is on a continuous graph, every single point, even between the dots, is part of the solution set. Whereas in a discrete set, only these points are part of the solution set. Anything in between wouldn't necessarily count. So what would that look like? Why would there be a situation like that? Well, this would kind of show up as if you're talking about selling an item and you can only sell one item or 2 items or 3 items. It wouldn't make sense to connect these dots because you're not going to sell a half of an item if you want to know how much money you're going to make or something like that. So if you're comparing items to amount of money, that would be a discrete set because you're not going to have a half. But if, for instance, you're calculating how many miles you get for a gallon or something like that, you can buy parts of a gallon or you can go parts of a mile. So there's always going to be those fractions in between the whole numbers that count. Okay, so if you're including fractions and parts of a whole, it's more likely going to be continuous. And if you're only counting whole numbers, that's going to be discrete. All right, so we're going to talk about what kind of solution sets fit all these different types of situations. So let's slide down to situation number 1. We're just going to go through one today real quick. So suppose Miguel begins with $500. It's important that he begins with that. And then he adds $20 a week. Now, for me, I already start kind of writing an equation in my head. That's where my mind goes, and maybe some of you do that too. But if not, there's lots of different ways to approach this. So first of all, what's an acceptable domain for the number of weeks? Domain is kind of like the solution set. We're talking about types of numbers. So we talked about these integers, real numbers, whole numbers, things like that. Different sets of numbers that represent different types of situations. So what's the acceptable domain for the number of weeks? Now you might say, well, you can have a half a week, right? This is acceptable. We don't travel through time 1 week at a time. We have partial weeks. But in this situation, we're talking about adding $20 per week. To me, and just in general, that sounds like once a week he's adding $20. He's not adding a little bit every single day that comes out to $20 a week. That would be different. In this case, it seems like once a week, maybe on a Sunday or a Monday or whatever, he's adding $20. So once a week. So it's just literally you have a 1 week and then you have a 2 week and then you have a 3 week. You're not going to have a 3.5 or a 4.5. It's going to stay consistent from that point of the week. So let's say he put $20 in at the beginning of the week. Halfway through that week, he still has the same amount of money in there. So it's not going to change on our graph, right? It's going to stay at that amount of money until the next week comes, and then it jumps up. So if you start thinking about what that's going to look like, that's going to look more like this. He puts a certain amount of money in, and then as time passes, he still has that amount of money until it jumps up because he put more in. He's not consistently putting money in every single day, every single minute, where you can kind of calculate how much money. There's going to be a little bit more than that extra $20 after maybe a day or two. No, he's putting it in once a week. So it's going to jump up $20, jump up $20 once a week. So when we're picking the domain for the number of weeks, when we're representing weeks, we're not going to have fractions or decimals. You're not going to have 1.5 weeks or 2.8 weeks. It's going to just be whole numbers. So we want to make sure that we don't just say, let's go with integers. Now we wouldn't say real numbers because real numbers are your fractions and decimals. So those are out. So integers, those are your whole numbers, but these also include negatives. And if we're talking about weeks, we wouldn't say negative weeks. So we want to specify positive integers, but you could have 0 weeks. Your starting point is 500. So we want to include 0. So positive integers and 0. So this is a good way to say it. So again, integers are your whole numbers. No fractions, no decimals, but we don't want negatives, so just positive integers. Now there's actually a group of numbers that you can just sum all this up with, and it's also called whole numbers. So whole numbers don't include negatives, and they do include 0. So you could just say whole numbers, but you also want to start and get used to the vocabulary of integers and real numbers. So in this case, whole numbers, positive, 0, those are positive integers, not real numbers. So letter B now. Let's complete the table for values of which W, that W is greater than or equal to 0 or less than or equal to 5. So this may look a little different than things you're used to. What this is telling you is when you start filling out your number of weeks, we're going from 0, it's included. Notice that equals. Okay, so from 0 to the numbers that are bigger than 0, but are less than or equal to 5. So basically, you're just going from 0 to 5. So as we start to fill this out, we're going to go from week 0, week 1, 2, 3, 4, and 5. That's what this wants us to do. Okay, greater than or equal to 0, less than or equal to 5. So let's figure this out. He's starting with $500. So at week 0, he hasn't added anything extra. So at week 0, we're going to be sitting at 500. And now every single week, he's going to add $20. So after week 1, you've got 20 more. So now it's 520. After week 2, he's going to add another 20. So 540. You can start to see the pattern. This is a continuous increase. It's going up the same amount consistently. So after 3 weeks, another 20. So every week plus 20. All the way up. So 580. And after 5 weeks, he's at 600. So if you flip to the back now, we're going to make a graph for this. So we're going to kind of have to flip back and forth on this sheet. So we're going to graph the ordered pairs from your table. So when they say ordered pairs, we're talking about the X and Y value, and you put those on your graph. So these are going to be our ordered pairs. So if we were going to write them out, we've got 0, 500 coming right from here. 1, 520. 2, 540. 3, 560. 4, 580. And 5, 600. Now you don't have to write them out. You can pull them straight from the table, but I just want you to see the relationship, okay? We've got an ordered pair of the X and the Y. These are the X and the Y values when you go to put them on the graph. So these numbers are where the ordered pairs are coming from. So if we want to start to think about how we build our graph, we've got to go from 0 to 5 on our X-axis. That's left to right. And we got to go all the way up to 600. But when we space that out, we're not going to be starting at 0 when we start putting our points. So there's no point in having a big amount of space. So we kind of want to get down to that 500 pretty quickly. So you could start with 500 if you really wanted to, or you could start with 0. For the sake of this graph, I think we can start all the way up at 500 if we wanted to. So let's flip this over. So going across the bottom, The X is your weeks. And anytime you're talking about time passing, we like that on the X-axis, weeks passing, so that you can see, okay, as time passes from left to right, what's going on? Is it going up? Is it going down? So we're going to start here at 0. And now you could go 1, 2, 3, 4, 5. But let's skip some lines so this gets spread out nice. So I'm going to kind of go every other line. 2, 3, 4, just to spread out the data a little bit. So technically, every single line is a half a week. But again, we're not plotting half weeks. Okay, this is going to be a discrete graph where the dots are just going to be on each particular week. We're not going to connect them because he's not adding money throughout the week. It's once a week, once a week, once a week. All right, on the left side now, our starting point is 500. So if we wanted to, you don't have to start at 0 here. You can start at 500. And I think that's best because, like, let's say if we started at 0 and we went up to 100 and 200 and 300 and 400 and 500 and 600, all our points are going to be in this little tiny area up here anyway. So let's kind of spread them out. We're going to go for this specific graph from 500 to 600. So let's start our graph here at 500. As we start to get into graphing calculators, this will be your window. So the y value is greater than or equal to 500. And now we got to go to 600. Let's spread this out. So let's call this maybe 510. Skip. 520. Hopefully this works out. 530. 540. Looks good to me. 550. So, it's basically every line is 5. 5, 10, 15, 20. I'm just not writing every single one. 25, 30, 35, 40, 45, 50, 55. 560, 570, 80, 90, 600. Okay, so I'd like to see my data spread out throughout this graph instead of bunched up here or just all up here. So I'm starting at 500, going to 600 throughout this whole graph. So at 0, if we go back to our points, at 0, it's 500. So if I go to my graph, I need a point at 0, 500, which is going to be right on the corner on this one. And then after 1 week, we've added $20. So based on this, X is 1, Y is 520. So after 1 week, we're at 520. Now, one thing I forgot to do was label what these numbers represent. You always need to label it. So this is the amount of money. You could just call it money, but this is in an account. So be more specific than just money, because money can be any situation. It's how much money is in his account. So it's his account balance. Okay, and then after 2 weeks, we go back to our ordered pairs. After 2, he's at 540. So follow 2 up and put it on 540. And then you're just going to keep adding 20, so I'm not going to flip back and forth. We know at 3, he's going to add another 20, so he's going to be at 560. So if I follow 560 over and line it up with 3, and if you see, this is going to form a nice straight line. And some of you are going to want to connect it. But again, don't connect it because he's not putting money in. He's not going to have, if you connected it, you'd be saying he has $510 after half a week. But that's not true because once a week he's putting money in. He's not putting money in halfway through the week. So I can't connect this line and include all of this data that's in between. Just positive integers, whole numbers. Okay, so 4 goes from 560 to 580. And then week 5 to 600. So again, your tendency is going to want to draw that line, but you need to think about the situation. Sometimes a line makes sense. Sometimes a line does not make sense. And in this specific situation, it doesn't. It's once a week. He puts in that $20. There's not a continuous increase in money throughout the week. All right, one last thing to do now. Write an equation that represents the total amount, T, in terms of the week. So we're talking about how much money. Well, this doesn't even make sense. So we want to write an equation that represents the situation. So basically we want to know how much money is in the account based on how many weeks we're in. So let's fix this. Write an equation that represents the total account. And let's not do T because we're not doing time here. Let's do B for balance. So we're going to write an equation that represents the total account, and we're going to express that as B in terms of the weeks. So we're going to write an equation that solves for the total balance if we plug in for W. So if we know how many weeks it is, we can plug into the equation and it tells us exactly how much money. So as we start to build this equation, you're always going to have a starting point. Sometimes you start at 0, but in this case, our very start point is 500, right? That's how much we started with. So when you start to write your equation, you can literally start with that. Think about this in practical terms. You started with 500, and then you're adding something every single week. How much are you adding? You're adding $20 every week. So if it was 2 weeks, you'd actually be adding $40 because you do 2 times 20. If it was 0 weeks, you plug in 0. 0 times 20 makes this disappear, and you've got 500. If it was 10 weeks, 10 times 20, and you add it to the 500. Okay, so this is going to be our equation that solves for the account balance, B, in terms of W, the weeks.